if you read the theorem in the book, it says that you have to split this into two, and you get to pick where you make the split point. I almost always make it at 0 because I like plugging 0 in. So this is for me now, but you can do that's where I would have split it. You can split it 1, you can split it 2, you can split it pi halves, whatever suits you, but I like 0.
So you have to do F of the fundamental theorem twice and add them together?
But if one of them blows up, that's the end of the problem.
Okay.
So let's see.
So if one of them hits infinity.
This one, they both work.
Diverges?
Yeah, then it diverges. If either piece
Goes with the-
diverges, the whole problem is said to
Yeah, 'cause
diverge.
it's infinity plus
I
infinity.
used to worry about, what if I got infinity minus infinity?
But it's still infinite.
Yeah, we don't bother trying to fit it into a L'Hopital's or anything like that. The definition says if one of them goes to infinity, that's the end of the problem. Okay, so do you recognize what this integral is? Yes, it's another arctangent. So we have arctan of e to the x. U squared is e to the 2x. U squared is e to the 2x. So u is e to the x. Du is e to the x dx. So that's a cute little arctan. And first we're going to evaluate from negative infinity to 0. And I'm going to do this my way, lazy. Fundamental theorem. Plug the top number in. Put a minus sign. Plug the bottom number in. E to the 0 is 1. Arctan of 1. Pi over 4.
Because
E to the
E to
0
the 0
is
is
1.
1.
Oh, okay.
And then you
I thought
still
you
have to
were
take the
doing
arctan of it. Yeah, you haven't done the arctan part yet. Okay, do that part first. What's e to the negative infinity? It's really 1 over e to the infinity.
Which is 0.
Yes, so we really are looking for the arctan of 0. That you can get off your calculator. It's 0.
0 minus 0, and then it's plus.
All right, so now we're going to do plus arctan
What's the
e
quantity
to
of
x from 0 to infinity.
infinity?
So that's arctan e to the infinity minus arctan e to the 0. Be careful, this one's so tempting to get the wrong answer.
Is that 0 again?
Infinity, isn't it?
We did this
Pi over
earlier.
2 minus 1.
Yes, this is pi over 2. This is pi over 2. That's that vertical asymptote for the tangent graph, which when you flip it over to make it the inverse, it's going to pi over 2. This is the arctan of 1. What angle has a tangent of 1? Pi over 4. So we take our two pieces, we add them together,
And there's just pi over 2.
pi over 2. So this thing converged, and it converged to pi over 2. So in the back of the book it'll say converges, and then it'll give the pi over 2 for the answer.
So arctan to the arctan.
Of infinity
Infinity
is
is
pi
pi
over
over
2. Oh, sorry.
And arctan of negative infinity is
Zero.
zero.
Is negative pi over 2.
No, zero.
No, it isn't.
Why was it zero though?
That was arctan e to the negative infinity. That pushed the e down in the bottom and made this arctan of 0.
Zero.
But the arctan of infinity, I'll write you a little list. Hang on a second. Is it okay? Yeah. I just thought, better let me write it, because that way, arctan of infinity is pi over 2. Arctan of negative infinity is negative pi over 2. The other one that you see a lot is arctan of 1, and that's pi over 4. If you do see an arctan of negative 1, that's negative pi over 4. The limit as x approaches infinity of a constant over x to any power, positive power, that one goes to, yes, that one goes to 0, but the limit as x approaches 0 from the right of 1 over x, yes, that's infinity. Oh, and the limit as x approaches 0 from the left, it goes to negative infinity. Okay, I think that's an okay summary of the little limit things that we've done. Okay, so now just a few wrap-up things. This whole topic came about as the result of what are called improper integrals. Improper integrals come several different ways, either in upper, lower, or both upper and lower infinities on the integration, or a vertical asymptote at a lower or upper, or within. And when that happens, we're still going to use the fundamental theorem, but we do it by really replacing with a dummy variable. If you've got your books, take a look